Let's go and look at some general solutions. Trigonometry grade 11. As you can see on the screen, we've got some questions, the heavy ones, the challenging ones. I'm only going to do at least 4 of them, if not 5. Let's go and have a look at them. Just the challenging ones, they are all challenging, these ones, I believe. Let's start from this one, number 1. We've got cos, just a moment. We've got cos of theta, which is said to be equals to negative cos 2 theta. So if you've got this situation, as you can see, we've got the very same trig ratio. Because we've got the very same trig ratio, now we'll go for the signs here. We've got positive sign there, we've got negative sign there. So where cos is negative, we should be talking about quadrant number 1 and quadrant number 4. So let's start with quadrant number 1. Quadrant number 1, we will have to equate the angles. We'll have to equate the angles plus 360k and to write k element of integer. So from there, we'll have to solve for theta. This will be negative theta equals to 360k we just need to write k element of integer once. If you can write it there, it's fine, or you can write it at the end, it's still okay. Then from there, you can divide by -1, then this is your final answer here. This is your first answer there. Then let's go and look at the next one here. Let's say quadrant 4. And talking about quadrant 4, we're going to say theta. Okay, I need to write well. Theta equals to quadrant 4, we've got 360 minus here. 360 minus the angle on the right, which is 2 theta. So we're going to say 360 theta equals to 360 minus 2 theta plus 360k k element of integers. Then we're now going to have our 3 theta equals to that 360 plus 360k. Okay. Now we can divide by every time by 3. This is what we're going to get. theta equals to 120. Plus 120 K. This is what we have. All right. So that's all with this first one there. So this is the solution for 8.71.1. And here we're working for 5 marks, as we can see. That's level 3 question. It's a higher grade question. And level 4, it's a higher grade as well. So level 3 and 4 here are higher grade. Let's look at number 2. Let's look at number 2. Number 2, we've got 2 minus 11 sine theta cos theta plus 3 sine square theta equals to 0. This is what we have. So what we need to do for us to do this, because we've got sine cos here, because we've got sine cos there and sine square here, meaning that what we're lacking is cos square. So for us to find cos square, we need to apply what we call square identity. And square identity, let's go and apply it. Square identity, we can apply it here. We can say 2 times 1. 1 is the same as sine square. One is the same as sine square. Plus cos square. Minus 11 sine plus 3 sine square just a moment. Sine square equals to 0. So once you have this, now you can work it nicely. So you had to remember this. Why? Because we've got the mixture of what? Sine cos there. So whenever you come across sine cos, then you need to apply square identity. You need to apply square identity, all right? Now, from there, let's see. We can have 2 sine square theta plus 2 cos square theta minus 11 sine theta cos theta plus 3 sine square theta equals to 0. Let's rewrite this nicely or simplify. We can have 5 sine square theta minus 11 sine theta cos theta plus 2 cos square theta equals to 0. So we have reached the stage where we need to factorize. We can use 5 sine we can use 5 sine minus only cos here and sine minus 2 cos. Then from there we can now have 5, or we can simplify it. We can solve for sine quickly here. We're going to have, okay, let's have this way. Let's say 5 sine theta equals to cos. Like this. Then we can divide by, we can divide by cos first to have 5 tan equals to 1 until you have your tan like this. Okay, then the next one there, you can have sine theta equals to 2 cos. Okay, 2 cos. Oh, then you divide both sides by cos, then you can have your tan theta equals to 2. Then of the 2, you can work nicely. We understand for tan, where tan is positive, that has to be quadrant 1 and 2, quadrant 1 and 4, but I'm only going to use quadrant number 1 since the angle should always be smaller than the period. The angle should always be smaller than period, and that applies only when we talk about tan. So for tan, we can go for one quadrant where the angle will be smaller than the quadrant. Look at here, quadrant number 1. Firstly, we can look for reference angle. Reference angle, that should be tan, second function, tan 1/5. That will be, we need the calculator now. So second function tan 1 over 5, that will be 11 comma 31, and 11 comma 31, theta will be equals to that 11 comma 331 plus 180k element of integer. This is when we talk about tan. But if say you wanted to use quadrant number 3, you are going to say 180 plus 11,31. That would be somewhere around 190 something, which is greater than 180. That shouldn't be the case. Always use the quadrant where the angle will be smaller than the period. But that only applies for tan. Remember that. For sine and cos, we use both quadrants. All right. Now let's talk about the second one. Reference angle here. Second function tan. Two. Okay. Let's see. That will be 63,43. Comma 43. And now for this one where the quadrant is positive, again quadrant 1 and quadrant 1 and quadrant 1 and 3. So I'm going to use only one quadrant in this case. I'm going to use what? So I'll say theta equals to that 63,43 plus 180k element of integer again. And that's that. Lot of work. That's why they say 7 marks. So that's that. Okay. Let's go and look at I'll look at the last two now. Let's go and check this one of 9 marks, which is, let's see, is it this one? 9 marks, this one. Nine marks will be number 5. Let's see. Does it qualify to be 9 marks though? I think it's easy, but only to me. It is easy, but to me. So let me do it with you guys. This is number 5. We've got tan theta equals to cos theta. So first thing first, I'm going to apply the quotient identity. I'm going to have cos theta and cross multiply. So I could have this cos square. After that, I'll rewrite it nicely. That will be cos square theta minus sine theta equals to 0. Then from there, I will apply square identity to say this is 1 minus sine square theta minus sine theta equals to 0. I'll have to rewrite this nicely. That will be sine square theta plus, I see quadratic formula here. I see the use of quadratic formula. Minus 1 equals to 0. Like I said, you will never factorize this. Instead, you're going to use quadratic formula, of which we know now how to do that. We know how to apply quadratic formula. Sine theta equals to, sine theta is our x, negative b. So the 9 marks is the application of quadratic formula, of which, guys, you know I'm not gonna do much there for quadratic formula. Leave your answer to 2 decimal place. I'm going to use my clever calculator. So let me use my clever calculator. I'll take sine as x. I'm going to take sine as x. So x squared is the same as sine square plus x minus 1. So here, okay. I need my answer as decimal. Can I have those as decimal? Yes, I can. I can have them as decimal to 2 decimal places. The first one will be negative 1,662. The second one will be 0,62. So this one, guys, will be no solution. This one, no solution. Why? Because the minimum is already below negative 1. The minimum must be the basic. If you remember well, the basic sine graph, its minimum is negative 1 and its maximum is positive 1. So for us to have negative 1,62, it means the minimum here, we're talking about the number below negative 1. That's why using your, if you attempt or if you try to find the reference angle of this, you're going to get undefined. So this one will be no solution. You can check wherever you are, you'll see what I mean. But for this second one, the ref here, will be what? 662. Okay, need to write well. So ref angle second function 0.62. The answer here will be to 2 decimal place. Let's see what we're going to have. So second function sine 0.62, and that will be 38.32. 38.32. Oh, no. No. Okay. Yes. 38.32. Okay. (38.32). So from there, we're going to look at where sine is positive. That will be quadrant number 1 and quadrant number 2. So quadrant number 1, that will be theta equals to 38.32, that plus 360k k element of what? Integer. And quadrant number 2, my pen is so tired now. Quadrant number 2, theta equals to 180 minus 38.32. Let's see. That will be 141.32 plus 360k. K element of integer. Wow, all this 9 marks. 9 marks, it's a lot. We had to work. We had to work there. We had to work. 9 marks, it's a lot, guys. But I hope you'd have enjoyed this one. Tough questions, beautiful to work with. Just beautiful. So let's go and do the last part, the last one, which will be number 12, the last question. Number 12. We've got sine square x plus 2 cos square x minus 1. the same minus. Should be easy. And that's for 8 marks. Should be x equals to 2 sine x cos x. Okay, remember what I said earlier, what I told you, that if you've got sine cos attached to each other like this, you need to go and make sure that you remember the square identity. And the square identity in this case, we're going to apply it where there's only the constant number there, where there's constant. And where there's constant, our constant there is -1. So our constant is -1. We're going to do like this. We'll say sine plus 2 cos square x minus into, now you'll come across this sine square plus cos square equals to 2 sine equals to 2 sine cos. Yes, like this. So from there, let's simplify. I'll just copy this again because now I am tired, guys. Already I am tired. That's why I do this. I just want us to finish this. And copy and paste. But after pasting, I need to take out this. Then here will be minus. So this is what I'm going to have. And simplify again. Sine square will take out sine square. Then you now have got 2 cos minus cos. That will be cos square equals to 2 sine cos, like this. Then from there, told you that this one, it's easy, I told you. So cos square minus 2 sine square, minus 2 sine cos equals to 0. Then I can factor out cos. I'll have cos there. See how easy is this? Cos definitely need to get another tab. This one is giving me a problem now, guys. So sorry about that. I'm so sorry about that. This is what I'm going to have. Then from there, cos equals to 0, or 2 sine equals to cos. I've just wrote this nicely. I wrote this nicely. From there, I divide both sides by 2 cos. That will be tan. Here will be tan x equals to 1 over 2. Of course, I'm nearly done. So let's go back to cos here, the reference angle here. If you remember your special angle, you won't have a problem. Second function cos that should be 90. Here should be 90. And where cos is positive, equals to 0 is the same as to say positive. So cos x equals to 0 is the same as saying cos, where cos is what? Positive. And that should be quadrant 1 and 4. So in quadrant number 1, we're going to get x to be just 90. In quadrant number 1, x will be just 90. So my pen is now acting up, guys. My pen is now acting. Just a moment. My pen is just acting. So you're going to have x. Yes. Now it's okay. X equals to 90 plus 360 k element of integer. That's the first quadrant. And in the fourth quadrant, x will be 360 minus 90, which is the reference angle, to be 270 plus 360k. K element of integer. So that's it for cos. What about tan? Tan, we're only going to talk about one quadrant where tan is positive, and the one quadrant we can talk about is quadrant number 1. So we're going to say ref angle here. I remember well here what's gonna be a ref angle second function tan half. This is 63,43. I remember that very well. 63,43. Check. 63,43. Am I right? Or is it for 2? Let's see. Half. 26, not 63. 63 is it's the second function tan 2. Tan 2 60. Let me confirm that. 2 exactly. Second function tan 2 is 63,43, but second function but second function tan half, that's 26,57. So 26,57. Okay, and where tan is positive, first quadrant and third quadrant, remember I said you can only write one of it, which where the angle is smaller than the period. That will be first quadrant in this case. So x equals to 26,57 plus 180 k 180 degrees k element of integer, and that's that. So 8 marks here. So look at, guys, we just worked from this one, 4 of them. These were very nice to work with, very nice questions to work with. You can see, guys, these are very nice questions. Not where, these are very nice questions to work with. So I believe, guys, you would have enjoyed these sessions, and don't forget to subscribe, hit the like button, so that whenever I post another video, you may have a look at it. You may be able to see, hit the notification or the like button, so that next time you may be notified, and leave your comments below. Until we meet again next time, love you all, guys. Bye.